It's beginning to look a lot like Christmas here in Mr. Newbold's room. Yeah, thanks for watching. So we're helping you today on 5.4 with graphing and trying to find different boundaries, domain, range, vertical asymptotes. And let's see here. But first, we've got a picture of me with my dog. There we go. Oh, I keep pushing the wrong one. Ooh, there we go. Yeah! It's coming up. Happy holidays! And I also got a new fireplace. Woo! Got a new fireplace for Christmas. Woo! Yeah, new fireplace. Whoa, I decorated my house with candy canes and icicle lights. Yeah. So it was a lot of work, but it was worth it. It looks amazing. So we're taking a look here at 5.4. So number one is review to find out if it's a factor or not. You can do synthetic division. You can just plug it in. Because it's just an x minus 1, pause me. Because it's an x minus 1, pause me, Newbold. No, just pause me because I want you to try each one on your own. Remember? Try it on your own, then push play, see how you did. Let me see here. Yeah. So x minus 1 equals 0. So we're going to use a positive 1. And we're just going to plug it in everywhere we see an x. And if we get 0, then yes, it's a factor. If we get 0, then yes, it's a factor. So 1 plus 6 times 1 squared is just 1, so 6. Plus 5 minus 12 equals, so that's 12 minus 12, which is 0. So yes, it is a factor. And the remainder is 0, yes, it's a factor. So don't forget for number 2 that you have to list all of the different factors. So 1 and 45, 3 and 15, 5 times 9, 6, 7, 2. Yeah, so find the exact value of all the zeros, show all your work. And so I'm going to use either those ones or maybe negative ones to look at, remember? And so which one of those is going to work? So use synthetic division or plug it into your calculator. Whatever one gives you a remainder of 0, that's one of your factors. And then do synthetic division and then factor your answer. So don't forget how to do that. Do you remember how to do this? Square root. So 50 divided by 2 is 25. So we get 25. We have 1x there. Pause me. Try number 3 on your own. It's a good review question. Try it on your own. So x cubed, take away an x, is x squared. And then all over, we still have a big radical. So y to the 7th power, wow. So that's 1, 2, 3, 4, 5, 6, 7. So square root of 25 comes out as a 5. X squared comes out as just an x. And then 1, 2, 3 y's. So that's 5xy to the 3rd power with still a radical y in there. Woo! Try number 4 on your own. That's a good one. Number 5 as well. That's a good one. To remind you how to do those. Number 7 is a good one. Make sure that you get a common denominator, right? So x squared minus 9 factors into x and 3 and 3. There's no middle term. No middle term, remember? No middle term. Oh yeah, you can be a little closer. You're kind of far away there. There we go. Make sure we're still recording. Good. Okay. Oh, hi. Oh, hi. There you are. Yeah. Okay, let's see here. So, yeah, we can pull out an x here. So we're left with x plus 3. So that's good. Over here is the same thing. Pull out an x, and we're left with x minus 3. Good. So we have to get a common denominator, and then eliminate the bottom and solve for the top. Remember, solving rationals. And so let's see. So this guy, the middle one, is actually missing an x. right? It's actually missing an x, so we're going to multiply it to the bottom and the top. Good. And then this one's done because it has a common denominator. This one is missing what? This one is missing the, no, it's missing the x plus 3. Missing the x plus 3 there to the top and bottom. So we're missing our x plus 3 there. And now this one has a common denominator. And then this one is missing an x minus 3. And so we're going to multiply that to the top and bottom. Now remember your restrictions that x cannot equal, remember your restrictions? That x cannot equal a positive 3, a negative 3, and a 0. Pause me. Try the rest of it on your own. You got this. Take out the training wheels. Try it on your own. So make sure we don't get a solution of 3 or negative 3 or 0. That could be a problem. Okay, so now that we got a common denominator, we can go ahead and eliminate the bottom and solve for the top. Nice. Only because of the equal sign can we do that, right? Only because it's the solving rationals. So then we go ahead and x times x is x squared. X times 2 is minus 2x. Negative 3 times x is a negative 3x. Negative 3 times negative 2 is a positive 6. Then we get a plus 8x, so plus 8x equals x times x is x squared. X times 3 is 3x. Negative 1 times x, no, positive 1 times x, and then positive 3. So we want to combine like terms, get everything to the other side. Interesting. So if I minus the x squared over to this side, that actually goes away. And then this is 4x that we minus over to this side. Minus 4x over to this side. So we get 4, 5, 6, 7, 8, 9. So that's a negative 9x. Ooh, with a positive 8x is negative 1x. And then we have a 6 left. And we also have a positive 3. So a 6 and a positive 3 is 9. No. We have to minus 6 over to this side. And so that's going to equal a negative. That's going to equal a negative 3, because 3 minus 6 is negative 3. Yeah. And then we divide by negative 1. Divide by negative 1. So we get x equals positive 3. Yay, positive 3. No. Why is it no? Because that's one of our exclusions. X can equal 3. Oh, what the woo? No solution. No solution, actually. No solution. So all that work for no solution. But at least we didn't build the bridge and collapse on anybody, because we found there was no solution for that one. Okay, awesome. Match the function with its graph without using a calculator. Whoa! Well, we could use the vertical asymptote to help us, right? We use the vertical tote there. And so we set it equal to 0 or not equal to 0. So set it equal to 0. And this is going to be our vertical tote. So we're going to add 3 to the other side. So vertical tote there is x equals 3. Okay, so which one of these? Is it this one? No. Which one has a positive? We're looking for a positive 3 right now. Looking for a vertical asymptote at positive 3. That's this one's 4. This one's x equals 4. Oh, here it is. Look at that. Yeah, there's a VA at x equals 3. And then this one is a negative 4. And so there's a vertical at x equals negative 4. Good. There's a vertical. Nice. Okay, so I'm thinking we got D. Is that right? Thinking we got D. So let's take a look there and see if D is the right answer. Let's see here. So we got D is what we're looking at. I'm going to pause you for a second there. Yep, looking good, right? Looking good. There we go. So D's right. So you try number 8 now. You try number 8. You try 10. Try number 12, 13. What about 11? So 11, let's see here. So 11, we have two things going on. We have, first of all, this guy. So that can't equal 0. And so that means we have a vertical, we have a VA at 0, right? And so that's along the y-axis. That's along the y-axis. Good. So I'm thinking it's probably C, but it also could be E. Ugh. So it could be C. Could be C or E. Ugh. Oh no, what do we do? Could be C or E. So what we could do is we could look at the horizontal. If I've taught you that, I don't think I taught you that for this lesson yet. Let me think what else we have to distinguish, right? Distinguish between the two. Let's see. So the only thing I can think of is, let's see here. Yeah, the only thing I can think of is showing you the horizontal, which I don't think we even learned in this lesson yet, did we? So the horizontal asymptote is it goes along right here at 4, and also goes along here at -1. And so that's the horizontal at y equals -1. And then over here is the horizontal at y equals +1. So that's the only thing, I mean +4, sorry, +4. So that's the only thing I can think of that's easy to distinguish there, right? So we look at the powers, and we look at the highest power, and so we basically have -x to the first over x to the first. And so I see in there that we have a -1 right there over 1. And so because of that, we have y equals -1 over 1, which is -1. And so that means it's got to be E. So number 11 is E. So pause me now and you try number 13 on your own. So go and pause me, try number 13 on your own. Let's see. Awesome. I guess we could also have set the top equal to 0, and that also helps you find the x-intercept, or the y-intercept. No, x-intercept, which should also be at x equals 1. Yeah. So x equals 1 there. You also could have done that. So we take 1 minus x, and we set that equal to 0. And we add x to the other side. And so we get x equals 1, which is also the x-intercept. So I think that could have been something too. I just feel like that's in the next lesson, but we'll keep going. Okay, beautiful. So then number 13, try 13 on your own, right? Try 13 on your own. We set this equal to 0. We minus 4 to the other side. So we're looking for a vertical at x equals -4, right? -4. So which one of these has a vertical -4? Let's see, that's +4. That's -2. Oh, there it is right there. So that's what that one is. That one's F. There we go. Nice. That one's F. Beautiful. All right, we'll do another video. Where are we at? We can do one more. Okay, so now it says draw a sketch of each function. Whoa, crazy. So let's try drawing a sketch of each function. And we can think about end behavior. And so this is the first power, which is odd. So it should then go like that kind of thing, like in opposite directions. Or this one is even. This one's even, and so this one should go in like the same direction. Cool. Let's see. So I mean, draw a sketch of each graph. So what I would do maybe at this point is maybe just go ahead and do an XY table. Why not? Do an XY table, right? And so we could go ahead and choose like values to the left and to the right. So like -3, -2, -1, 0, 1, 2, 3. Yeah. And so if we plug a 0 in, we get 0 minus 2, so we get -1/2. If we plug 1 in, we get 1 minus 2 is a negative 1. And so that's going to be, yep, we get a negative 1 over 1, which is negative 1. If we plug a 2 in, whoa, 2 minus 2 is 0. That's a bad thing. So if we plug a 2 in, we get 1 over 2 minus 2, which is undefined. Whoa, undefined. So that is actually where our vertical, right? Right? If you set that equal to 0 at 2 is where our vertical is. It's our vertical, or VA, vertical asymptote there. And then if you plug a 3 in, 3 minus 2 is 1. So you get 1 over 1, which is a 1. And so over 3 up 1. Good. Let's see here. At undefined, at over 1, down 1 is another 1. What if you plug a negative 1 in? So negative 1 minus 2 is negative 1/3. So that's going to be, and if you plug 0 in, you get a negative 1/2. Okay, interesting. And then if you plug a negative 1 in, you get negative 1/3. So that's just getting closer and closer to the horizontal. And so that's going to go along here and go down. And then this one's going to come along here and go across. And there we go. And that was number 14. I did the wrong one. I was supposed to do odd 15. What the? Okay, you try 15 on your own then, right? You try 15 on your own. And so give that one a try. Give that one a try. And do just like an XY table, right? So go and do an XY table. Except for this time, those x values are going to be squared. So we're not going to have any negative x values. That's interesting. So it's probably going to look similar. Probably just going up at x equals 2 is probably what's going to happen there for number 15 because of the squareds. Okay, so now do odds, Newbold, do odds. So here's number 17. Okay, I want you to find all the possible information, but we'll come back to that in our next video. Thanks for watching. See you in a second. Thanks for watching. We wish you a Merry Christmas. Whoa, thanks for watching. Happy holidays.